Hello everyone. I wanted to work this problem from the homework assignment. This is from 5.3. It's number 44. And it's a wonderful problem to tackle here because it gives me a chance to do a review of some early Chapter 5 stuff. And also, believe it or not, this problem incorporates a move that you'll see in Chapter 6. And so I'm going to begin here with the review, and I'm going to drag in a problem that is at first unrelated to the one up above. And this is a situation that we had earlier in Chapter 5 where we had to deal with minus parentheses and plus parentheses. And I suggested that you needed to learn how to handle those two situations automatically without thinking and quick step your way through them because they were going to appear again and again throughout the course. And if you remember, I said plus parentheses. The way you handle this is you simply erase the parentheses. And the reasoning behind that was essentially that really what you have here is a 1, a distribution in fact of plus 1, a multiplication of these two terms by plus 1. And multiplication by 1 or division by 1 doesn't change the value of what's being divided or multiplied. And so you could simply rewrite this without the parentheses. You could do the distribution and you would end up with simply this. Nothing gets changed by that multiplication by 1. And so how do you handle plus parentheses? Well, you simply erase the parentheses. Now the situation over here with minus parentheses was similar. We began the same way. We said let's imagine the 1 there, except now this is actually a minus 1. And we are distributing minus 1 multiplication to both of these terms. And I said multiplication by negative 1 is called by mathematicians a sign changer. So the net effect here is that the 2x will become a minus 2x and the minus 3 will become a plus 3. And the parentheses will drop away. And so, we end up with this situation here. And so, that's the way you handle minus parentheses. You simply change the value, toggle the signs of the things within the parentheses. And so that was a way to put these ideas on autopilot. And before we escape from this review, let's just take one more look at this idea of minus parentheses. Here again is another problem. And I know you could rewrite this immediately now without parentheses by just changing the signs of these four terms. And you would end up with this situation right here. And you would be correct. That's how you handle minus parentheses. Okay, but how does this tie in with the problem up above? Well, here's the thing. Suppose we started here. Suppose we started here, and I said I want to see the thinking, the algebraic thinking that can bring us here. In other words, I wanted to work this idea in reverse. And what's the thinking there? So let's create some space here, and I want to take you on a logical footpath from the top to the bottom here. Now my first move is we have here 5 terms. And to make it look like this, what I need to do is put some parens in here. And you need to get sort of an attitude about math that you can put parentheses in wherever you want. You have the power to do that. And so I'm going to do that. I'm going to go ahead and I'm going to insert parentheses where I want them, like that. And so I have made a legitimate move. I've inserted some parentheses. And now instead of multiplying everything by negative 1, what I'm going to do here is I'm going to factor out a negative 1. I'm going to pull a negative 1 out of these 4 terms. Now factoring is in effect division. So what I'm doing when I pull out a negative 1 is I'm actually dividing those 4 terms by negative 1. Which is very similar to multiplying by negative 1. It's a sign changer. So the net effect is when I pull out a negative 1 from those 4 terms, the signs have to change on everything within the parentheses. And so that's why the plus 3 becomes a minus 3, the minus 2x becomes a plus 2x, and so forth. I've factored out a negative 1. Now if you were to, well, the last step of course is to simply eliminate that 1 like this, and we have in effect gone backwards on this problem. As you can see, these two are identical. And we did that by factoring out a -1. Okay, so that's the idea to help us solve this problem up above. Let me go to the drawing problem here and bring in my pen. And so we have two terms here, and I could factor out an x minus 6 if this was an x minus 6. It's not. It's very close. And so the question is, how do I make it so? And so let me recopy this first part here. I'm going to factor out a -1. And see, what happens when I do that is it changes the values here. The plus 6 will become a minus 6, and the minus x will become a plus x, which is what this is. So by factoring out a -1, I can make this look like this. Now when I pull out a -1 from both of these terms, on the outside I have -1 times 2, which is the same as -2. And now I have a choice here. I can simply create an extra step and say, well, then plus 6 becomes a minus 6, and the minus x becomes a plus x. I can certainly do that. Or I could quick step the whole situation here and say, and rewrite. The minus x is going to become a plus x, and I'll put that first. And the plus 6 has become a minus 6, and I'll put that second. And now I have exactly duplicated the factor of x minus 6. So either way is okay. I prefer to go to a straight rewrite where I make the two factors identical. And now we have two terms. They have an x minus 6 factor in common, and what we're going to do is pull that x minus 6 factor out from both of those terms. And we ask ourselves, after we pull that out, we ask ourselves, what got left behind? Well, when this vanishes, it's the 5x squared that got left behind. And when this is pulled out, the minus 2 gets left behind. And so that is the correct answer for this problem right there. I've factored the expression, and I did so by the initial move of factoring out a -1. Now you may be saying, okay, well, how does this apply to what we're going to be doing in chapter 6? And so that's the preview. And let me go ahead and drag in one more picture right here. A very similar problem, I think you'll agree, except it is division. We have two fractions, and we are adding them, and they are similar. To add fractions, you need to have common denominators, and I'm very close to having common denominators here. How could I make them exactly the same? Well, that same move that we used up above. We would factor out a -1 here, and we would end up with this. Factor out a -1 and rewrite. The minus x becomes a plus x, and the plus 6 becomes a minus 6. And now the denominators are almost exact. All we have to do is deal with this -1 right here. Well, this is actually a division by -1. And a division by -1 is really the same as a multiplication by -1. So I could rewrite this up here without losing any sleep over the fact that that's a legitimate move. Of course, once I do that, this vanishes. I don't have an eraser here, so I'll just scratch that out. And so what we have here is similar denominators, identical denominators, and so we can follow the arithmetic on top. And this is a chapter 6.2 problem, rational equations, rational expressions. I follow arithmetic on top, and I get this plus a -2, and on the bottom I have my x minus 6. And so this is a very similar problem. This would be the answer. Nothing is going to cancel here. And I've now solved a chapter 6 problem and a chapter 5 problem using the same idea of factoring out -1, and when you do that you have to change the signs of everything inside the parentheses. Okay, I hope that helped and it wasn't too circuitous, but it's a nice review and a preview. I'll be talking to you soon.